Here we have a SAT math problem. Okay, let's go to the question. Square root of 48 times the fifth root of 81. The expression above can be rewritten in the form a times bth root of c, where a, b, and c are positive integer constants. What is the smallest possible value of a positive, b positive, c? Okay, here to get the values of a, b, and c, what we have to do is we have to rewrite the given expression in this form. Okay, let me take the given expression as it is. That is square root of 48 times fifth root of 81. Okay, here to simplify this expression, what we have to do is we have to write this 48 as a product of its prime factors. The same thing we have to do for 81 as well. Okay, now let me decompose this 48 into its prime factors. Okay, here 48 is an even number, so it can be divided by the smallest prime number 2. When I divide 48 by 2, I am getting 24. Again, 24 is an even number, so it can be divided by the smallest prime number 2. Then we get 12. Again, it can be divided by 2 because it's an even number. So when I divide 12 by 2, I am getting 6. Again, 6 is an even number, it can be divided by 2, then we get 3. Since 3 is a prime number, we have to stop the process. Now we can write this 48 as a product of its prime factors. That is 2 times 2 times 2 times 2 times 3. Now we have to do the same thing for 81. Okay, here when I consider this number 81, it's a multiple of 3 because when I add 8 and 1, I'm getting 9. 9 is a multiple of 3. So 81 is also a multiple of 3. So it can be divided by the prime number 3. When I divide this 81 by 3, I am getting 27. Again, 27 is a multiple of 3. It can be divided by 3. So when I divide 27 by 3, I'm getting 9. 9 is a multiple of 3. It can be divided by 3. So then I'm getting 3. Okay, so here 81 can be written as 3 times 3 times 3 times 3. Okay, here I got both the numbers 48 and 81 as the product of their prime factors. Okay, here inside the square root, instead of 48, we can write its prime factors. That is 2 times 2 times 2 times 2 times 3. And here times the fifth root of for 81, what we can write is 3 times 3 times 3 times 3. Okay, here we have square root. In square root, for every two same numbers multiplied inside, one number can be taken out. So for these two twos, 1, 2 can be taken out, and for these two twos, 1, 2 can be taken out. Then we get 2 times 2, and inside the square root, we have 3. That is the square root of 3. Okay, here we have fifth root. So when we have fifth root, for every 5 same numbers multiplied inside the root, one number can be taken out. But here we have only 4 same numbers multiplied. Since it's a fifth root, we need 5 same numbers multiplied inside the radical. But here we have only 4 same numbers. So we cannot do any more simplification here. So the only thing what we can do is we can write this product as a power, that is 3 to the 4th power. Okay, let me do it. That is the fifth root of 3 to the 4th power. Okay, here 2 times 2 is 4. And whenever we have radical, it can be written as an exponent. Okay, here when I write the radical as an exponent, the exponent will be a fraction with numerator 1, and the denominator over here has to be the index of the radical. Since it is a square root, its index is 2, so we can take that 2 over here. So now I have written this radical, that is square root as an exponent, then I'm getting 1 over 2. Okay, here the same thing we can do for this one, that is we can write this fifth root as an exponent. When I do so, the exponent will be a fraction with numerator 1. The denominator of the exponent over here must be the index of the radical, that is 5. Then we get 1 over 5. Okay, now 4 times 3 to the power of 1 over 2. Here a power is raised to another power. Whenever a power is raised to another power, what we can do is we can multiply the two exponents using the power of a power rule. Okay, when I multiply the two exponents over here, this 4 and 1/5, I am getting 4/5. Let me write over here. Here we multiply two powers with the same base 3. Whenever we multiply two powers with the same base, what we can do is we can add the exponents using the product rule of exponents. Okay, let me do it over here. That is 4 times. Now let me take the base ones and add the two exponents, 1 over 2 and 4 over 5. Okay, here we add two fractions with the different denominators. Whenever I want to do addition or subtraction between two fractions, I need the same denominator for both the fractions. For that, we have to consider the denominators over here. We have 2 and 5. Okay, now to get the same denominator, we need to find the least common multiple of these two numbers, 2 and 5. The least common multiple of 2 and 5 is 10. That is, we have to make each denominator as 10. Okay, for that, what I have to do is I have to multiply both numerator and denominator of the first fraction by 5. Okay, when I multiply 1 by 5, I'm getting 5. When I multiply this 2 by 5, I'm getting 10 positive. Here, I have to multiply by 2, then I'm getting 8 over 10. Okay, here 4 times 3 to the power of Here we add two fractions with the same denominator 10. Now we can take 10 as a common denominator and we have to add the numerators, that is 5 positive 8. Then we get 4 times 3 to the power of, when I add 5 and 8, I am getting 13 over 10. Okay, here from this step, we can proceed this problem in two ways. Okay, let me erase this stuff and continue over here. Okay, here we have two ways. Now let me continue the problem from this step in the first way. Okay, here my aim is to get a radical over here so that I will be able to get the stuff in this form, a times b to root of c, and you will be able to get the values of a, b and c. Okay, if I want to get radical over here, what I have to do is I have to get a fractional exponent, and also the fraction of the exponent should have a numerator 1. Okay, here we have a fractional exponent, but the numerator is not 1, it's 13. So now what we can do is 4 times 3 to the power of this 13 over 10 can be written as 13 times 1 over 10. Okay, here 4 times the exponent, two values are multiplied, 13 and 1 over 10. Whenever two values are multiplied at the exponent, what we can do is we can take one of the values as an exponent for this base 3, and the other value can be taken as an exponent for the whole stuff. Okay, here let me take the first value 13 as an exponent for this 3. Then I'm getting 3 to the power of 13. Now the other value 1 over 10 can be taken as an exponent for the whole stuff over here. Okay, then we get 4 times, and here we can write this exponent of 1 over 10 as a radical, and when I write this one as a radical, so it will have index 10, the denominator over here. Then we get 10th root of 3 to the power of 13. Okay, now let me evaluate the value of this 3 to the power of 13. So its value is 1,594,323, the value of this 3 to the power of 13. Okay, now this is exactly in the form we have over here. So comparing this and this, I am getting a equals to 4 and b equals to 10. That is, b is the index of the radical. Here the index is 10. And the c is the radicand, that is the value I have inside the radical, that is 1,594,323. Okay, so handling the problem in the first way, these are the values I'm getting for a, b and c. Actually, according to the question, we have to find the smallest possible value of a positive, b positive, c. Okay, now let me continue the same problem from this step in the second way. Okay, let me do it. That is 4 times 3. Now let's consider the exponent we have over here. It's an improper fraction because the numerator is greater than the denominator. Then we can write this improper fraction as a mixed number. Okay, here how many times this 10 goes into 13? 10 goes into 13 one time. So we can write 1. Okay, when 10 goes into 13 one time, so what do we have left over in 13? We have 3 left over. We can write this 3. And now we can take this denominator 10 over here. Here I have written this improper fraction 13 over 10 as a mixed number. Okay, 4 times 3 to the power of. Now what we can do is we can take addition sign between the integer part and the fractional part in this mixed number. Then we get 1 positive 3 over 10. Even when I simplify this one, its value is still equal to 1 3/10. 4 times. Here two values are added at the exponent. Whenever two values are added at the exponent, what we can do is we can take the base separately for each value and multiply the results. Then I'm getting 3 to the first power times 3 to the power of 3 over 10. Okay, here 4 times 3 to the first power is just 3 times 3 to the power of. We can write this 3 over 10 as 3 times 1 over 10. Okay, here when I multiply this 4 and 3, I'm getting 12. Okay, here at the exponent, two values are multiplied. Whenever two values are multiplied at the exponent, one of the values can be taken as the exponent for the existing base, and the other value can be taken as the exponent for the whole stuff. Okay, here let me take this value 3 as an exponent for this base 3. Then I'm getting 3 to the third power. The other value 1 over 10 can be taken as the exponent for the whole stuff. Here 1 over 10. Okay, 12 times. Here we have the exponent 1 over 10. Since we have a fractional exponent with numerator 1, this exponent can be written as a radical. When I write this exponent 1 over 10 as a radical, the index of the radical will be 10. Then we get 10th root of 3 to the third power. Then we have 12 times 10th root of, the value of 3 to the third power is 27. Okay, here I got the given expression exactly in this form, a times b root of c. Okay, let's compare this one and this one. When I compare them, at the place of a we have 12, at the place of b we have 10, at the place of c we have 27. That is A equals to 12 and B equals to 10, C equals to 27. Okay, here we got two sets of values for the constants A, B and C. So here we have the first set of values for A, B and C. Here we have the second set of values for A, B and C. Okay, according to the question, we have to get the smallest possible value of A positive, B positive, C. In which set we will be getting the smallest possible value for A positive, B positive, C? So definitely in this set, because when I consider this set of values for A, B and C, the value of C is very large. It's 1,594,323. So only in this set of values for A, B and C will be getting the smallest possible value for A positive, B positive, C. Okay, let's add these three values. That is A positive, B positive, C equals to 12 positive, 10 positive, 27. When I add these three values, I am getting 49. Therefore, the smallest possible value of A positive, B positive, C is 49.